Okay, folks, welcome back to the next part of this series. So what we need to do now in order to create a file and log the data to disk is we need to do what I call method 3, and it's pretty complicated. Right here, there's a right button presses to disk. And basically what you do is you import all the usual stuff and you import the switch. So there's a switch on here that it says D7. And so you basically create this switch on board D7, and button A and the LED don't really matter. But basically, if the switch.value is false, you open a file, and then if the switch value is false, you record the data and log it. Okay, and so what we're going to do first, just to get this to work, is we're going to grab, or just to start it going, is we're going to grab the switch, and we're going to just make sure that we can read the switch. And so we're going to open up the serial monitor, and we have the switch and everything is good. Now the difference is what we're going to do now is I only want the pixels to do something if we're taking data. So I'm gonna reset the pixels, and I'm gonna say pixel 0 is just 0, 0, 0 here. And then what I'm going to do is I'm going to check and see if switch is thrown, okay? Because I only want to take data if the switch is to one side. I only want to print, I'll leave the sleep in there, but I only want to take data if the switch is thrown. So now I'm going to say if switch dot value equals, and I need to check and see in the code, you want to check and see if it's false, okay? So I'm going to say false here, and I'm going to hit save. And so now it looks like the switch is definitely thrown. So if I flip the switch, now you see that the serial monitor stopped and the light is perpetually green. And so what I'm actually going to do is I'm going to reset here. I'm going to move the pixel reset into the while loop here. And that way, if I flip the switch, we will, right now there's no pixels. If I flip the switch, now we're taking data. We're not logging yet, it's just printing, and the LED is changing. And then if I flip it the other way, the LED turns off. And so now, again, if I don't have the serial monitor on, I know without a doubt that I am recording data. So the next thing that we need to do, I think, is when we flip the switch, we need to try and actually write to disk. So here is the line of code that writes to the disk. So I'm going to copy this over. And instead of printing to standard out, I'm going to comment that out, and I'm going to print to a file. And I'm going to do string t plus a space, then string x plus a space. Oops, that's not a space, that's a space. Plus string y plus a space, plus string z plus a space, plus string capital T, and then no space, and then a /n for a new line. And then I'm going to write the output, and then I'm going to flush it. Now when I run this, it's not going to throw an error until I flip the switch, and then it's going to say, hey, file's not defined. Okay, so I'm going to flip the switch back and hit Control D to reset. Now what I need to do is I need to, and you know what I should do? I should at least put a heartbeat in here. Yeah. So I'm going to do, I'm going to grab the LED. So here's the LED that's built in. And I'm going to throw that into here in the code and run that up there. So that sets up the LED. And then I'm going to do LED dot value is false. I'm going to turn it off. And then I want to turn it back on. I want it to cycle. I want to do LED is not LED.value. So if it's true, it becomes false, and if it's false, it becomes true. So even if we're not recording data, look at the serial output. I'm not recording data. That little LED is blinking. And the reason why I want that is because I at least want to know that the Circuit Playground is taking data. So now I think I am ready to open the file. So I'm going to grab this part of code, okay, that basically says, hey, if the switch is false, open the file. Okay, so the switch is false, open the file. And I'm going to call this, CPB data log, and I'm going to open it for writing. And so it's going to say, not opening file for writing, and then the LED should just blink. Now, if I flip the switch, it's going to say, hey, what are you doing? File's not defined. Well, now here's what happens. Let's say I reset it. If I reset it, it should try and open this file, right? So I'm going to hit Control D down here, and now it's going to say, sorry, you've got a read-only file system. So here's the complicated part that that happens when you're trying to log data. Oh, and then by the way, there's this flush here, and you know what would be very cool? You know what'd be cool is if like I was writing and then I flipped the switch, I closed the file. But I think it'll be fine. I think if you do the flush, I think that'll be fine. I don't think we're going to lose any data. So the issue is that on the CircuitPy, you need, and I need to make sure I do this properly, I need to flip the switch to not write mode, so not open file for writing. And what I need to do is I need to go find a program, come on, a program called boot.py, okay? So CircuitPlayground, CircuitPython, and in the data logging, D, there should be a file called boot.py. So if I throw boot.py over here, everything should still run just as normally, but here's the thing. If I look at boot.py, it imports the same stuff and imports the switch, and then it remounts the storage, the root file system of the CircuitPy, depending on the value. So if the value is false, it remounts it. Otherwise, it keeps it the same. And what that means is that you can write to disk when you do that. So here's where things get kind of sketchy. So right now, the LED is blinking, so I am in not write mode. I'm going to flip the switch, and it says file not defined. So then I'm going to reload the code, and normally if you don't have a computer, you would just reset it. But I'm going to reload the code, and then it's going to say read-only file system. The reason why it's a read-only file system is because that boot.py only runs on reset. So what I need to do is I need to get rid of the serial monitor, reset the device, and if everything works, we should see this LED blink. And that means I am logging data. And I know without a doubt I am logging data to disk because I have that LED on there. And the pixel, sorry, that's a NeoPixel. The interesting thing is that the LED over here is also blinking, which means I'm running through the while loop and I'm also logging data. So if I flip the switch, boom, the LED is blinking, which means the code is running, but the NeoPixel is off, which means I'm not writing data anymore. So if I go ahead and reset the device so that boot.py takes effect, I should be able to see, and everybody pray, I should be able to see on CircuitPy a CPP data log file, and there is all my files, which is awesome. So that is X, Y, and Z, and temperature, okay? So the second part of this video series now, and again, I'm not going to do that one more time. I would just recommend rewinding the video and rewatching that and making sure you understand how that goes. And from now, at this point, I am going to take this CPP data log file and I'm going to put it on my desktop. And then I'm going to open Tony, which is Python for my computer, not in Mu. And I am going to make a new function. I'm going to do import numpy as np, import matplotlib.pyplot as plt, and I'm going to data np.load text, and I'm going to import that file. And remember, it's called cpb datalog.txt. I'm going to hit save, and I'm going to save it on the desktop as plot datalog file.py. And it shouldn't throw an error, I hope. And it says it wasn't found. Did I spell it wrong? Of course I did. Capital, lowercase l. There we go. So now the data is in. I like to do a print shape is np.shape of data just to see that it imported properly. So there are 64 lines of code and 5 columns. So time is the first column. X acceleration is the second column. The Y acceleration is the third column. The Z acceleration is the fourth column. and then the temperature, capital T, is the fourth column. And so I should be able to throw in a figure, okay, and plt.plot t comma x, and I'm going to do, let's do a label, call this x, and then let's copy this 3 times, change this to y and z, change this to z and y, throw in a grid, plt.grid, throw in an x label, time in seconds, throw in a y label, acceleration in meters per second squared, and then a plt.show. And then I should be able to do the same thing, plt.figure and plt.plot t comma t, so lowercase t is time, capital T is temperature, and then throw in a grid again, throw in a x label, time in seconds, and then a y label in temperature in Celsius. And I think that should do it. So if I run that, x is not defined. What are you talking about? T is not defined. Oh, because I called it time, of course. There we go. So there's my acceleration. And I mean, I didn't really move it very much. And then there's my temperature. And so you'll notice, by the way, that the time starts at some ridiculous number. Sometimes it's good to do a t minus equal t of 0 to shift everything over. So that's a t minus equal t of 0. And so now everything starts at 0 seconds. So I didn't really move the circuit playground very much, but if you put this thing in a rocket or an airplane, you should get your accelerometer measurement and your temperature measurement as the thing is moving, which is kind of neat. So that concludes this part of the video series. The next part is adding Bluetooth and getting data sent to our phone. Now, Bluetooth is very short, but if you're just taking data like 20, 30 feet away, and say the circuit playground dies, you will still at least get your data on your phone. And so that will be the next video that I post.